let's go ahead and work out this difference here. And this is typically called a difference quotient. It's a difference because we're doing this subtraction, quotient because we have division. So here we're back to the same problem we just did, except now we're going to find this instantaneous speed by doing this limit. So what we have to do is the limit as h approaches 0. Our function's called s here, so we're going to do s of 2 plus h minus s of 2 divided by h. So to do that, the first thing I need to do is figure out what s of 2 plus h is. And what that means is I have to put 2 plus h inside of my function here. So everywhere I see t, I'm going to put 2 plus h. So I get minus 2, the quantity 2 plus h squared, plus 20, 2 plus h. Notice that where the 2 plus h's are, we'd had t in the original function. Basically, all we're doing is we're changing t to 2 plus h. So now let's try and simplify this. And the way we're going to do that is we're going to go ahead and square out 2 plus h times 2 plus h and then distribute. So when I square out 2 plus h, so I take 2 plus h times 2 plus h. First times first gives me 4. The inside and the outside are each 2h, so when we add them up we get 4h. Last times last, h times h, is h squared. Now let's go ahead and distribute. So when I take minus 2 times 4 plus 4h plus h squared, I get minus 8, minus 8h, and minus 2h squared. When I distribute the 20 onto the 2 plus h, I get 40 plus 20h. You'll notice that I have some terms here that I can combine together. So minus 8 and the 40, they give me 32. The minus 8h and the 20h, they give me the 12h, and the minus 2h squared doesn't have a term to combine it with, so I just transfer it down here. Now let's take that and put it in place of s of 2 plus h, and we'll also do s of 2, remember, which was 32, and then we'll work out this limit. So I've gone ahead and put s of 2 plus h in here. That's what we just worked out. I've put 2 into all of this stuff, and that's just going to become 32. And now let's go ahead and do the subtraction in the numerator here. The 32s are going to drop out, and so we're left with the limit as h approaches 0 of 12h minus 2h squared, all divided by h. Notice that 12h minus 2h squared can factor, so we'll pull out an h, and when we do that, we'll be able to cancel it with the 1 on the bottom, so we're only left with the limit as h approaches 0 of 12 minus 2h. Before, if we had tried to put 0 in anywhere up here above, we would have gotten 0 divided by 0. But now since we've canceled out the h, we're just left with 12 minus 2h here. So as h approaches 0, the second term is going to go to 0, and what we're left with is 12. That's the same answer we got from creating the table before, but now we've done this completely algebraically from the definition of instantaneous rate of change. Whenever you're asked to use the definition of instantaneous rate of change, you're going to have to go through something like this. So we now know that our instantaneous speed is 12 miles per hour. Let's do a business application. Suppose that the total profit in hundreds of dollars from selling X items is given by P of X equals 2x squared minus 5x plus 6. What we want to know is what is the marginal profit at x equals 4. Now you'll recall, what marginal profit means is instantaneous rate of change. So we need to find the instantaneous rate of change at x equals 4. Using our definition, the f changes to p, The A value is 4, so we're going to do the limit as h approaches 0 of P of 4 plus h minus P of 4, all of that divided by h. We'll go through the same process we just did. We'll try and cancel things out so the h disappears, and then we'll be able to do the limit. The first thing we're going to do is P of 4 plus h. So that means I need to put 4 plus h in place of all the x's. So I get 2 times the quantity 4 plus h squared minus 5 times the quantity 4 plus h. And if I go ahead and FOIL out 4 plus h, I get 16 plus 8h plus h squared. Now I'll go ahead and distribute onto all the pieces in here, both the 2 and the minus 5. Be careful of that negative. And what I get is 32 plus 16h plus 2h squared minus 20 minus 5h plus 6. So we'll simplify it a little bit more, so combine some like terms together. So what I'm going to put in is 18 plus 11h plus 2h squared. So that's going to go in place of the P of 4 plus h. So I'll have 18 plus 11h plus 2h squared minus putting 4 into the function, so 2 times 4 squared minus 5 times 4 plus 6. Now we need to start simplifying the top of that fraction. All of these numbers in the second part here, P of 4, just give me 18. And now I can go ahead and combine that with the 18 in this other piece in parentheses. So what I'm left with is 11h plus 2h squared over h, and I'm going to go ahead and factor out h on top. So I get h times 11 plus 2h, and now that h is going to cancel with the 1 in the denominator. So what I get is the limit as h approaches 0 of 11 plus 2h, and as h gets very small, that second term will be 0. Since the first term does not have an h in it, it's just going to stay as 11. So the answer here we get is 11. What are going to be the units on this? Well, the top part of our fraction here was probably in dollars. It was profit. And remember, the bottom part here was items. So what we're finding here is that this is going to be dollars per item. The marginal profit at 4 items is $11 per item. What that means is if we increase our production from 4 to 5, one item, that's going to lead to an increase in profit of $11.